Hey curious people, welcome back. Today I'm here with a very interesting phenomenon, lunar cycle. So, have you ever wondered at night that why on earth the the shape of moon seems to change every night? What's the reason behind that? And what is with that we always see the same face of the moon? So, have you ever wondered these type of questions? So, look here. You can see different shapes of the moon. Sometimes it's full, sometimes it's crescent, and this one is called gibbous. So, why does that happen? And why on the earth we just see one face of it, not the other side of it? So, if you have these doubts, then you are in luck today because I'm going to explain it today and right now. Let's begin. So it's actually a two-part question. Let's answer the second question first. That why do we always see this one side of the moon, which we also call the near side because it's near to us, the near to earth. For example, if this is the moon, so this side which is towards you is the near side, and which is away from you, this one is the far side. So we always see one side. Why is that so? And what is it called? Now this happens because of the tidal locking. You need to understand what is tidal locking. So I'm going to demonstrate you one thing. Just give me a minute and see what I'm trying to do here. Okay. Now look at my face and my hands. So I'm rotating, and just notice that this side of my hand, this side is towards me and this side is facing you. Now I'm taking rotation. I'm gonna rotate about my axis, and this hand is gonna revolve around my face. Notice it. Okay, let's begin. I'm trying to do this in a slow-mo. So I'm still seeing this side, and here we go. This is tidal locking, that this part of my hand is always facing towards my face. I'm not able to see the other side of my hand. So this is tidal locking. Now, how it looks in the case of the earth and moon. So this is earth and this is the pretty moon's face. So we can just look at the face but not at the back. Imagine it has a hair on the back of it. We cannot see that. Again, the face is visible to the earth. We cannot see the hair because those would be in the back. Since we are standing here, we can see the hairs. But anyone who is in the earth, standing on the earth, would be just able to see the face. Again, here we are just facing the face of the moon, right? So this is called tidal locking. And put it more scientifically, if you will. Tidal locking is a phenomenon when the orbital period of any celestial body is equals to its rotation period. So it's a kind of locking or synchronization. Okay, so given any binary system, so the lighter of the body becomes tidally locked to the massive one first. That's why this is the earth and moon is a real life example of that. So the lighter one is moon. So during the formation of our solar system, it took nearly 100 million years for the moon to become tidally locked to the earth. Okay, so initially its revolution period was not equal to its rotation period. Previously, actually, it was rotating much faster, but over the time of around 100 million years, it slowed down. And this is what we call tidal locking. Now it's locked. Its face is locked to the face of the earth, and hence on the earth we are just able to see one side of the moon, not the other side. Okay, so another thing which is very important here is that moon is tidally locked to the earth, not the other way around. Earth is not tidally locked to the moon yet. Okay, what does that mean? So look here again. So if you look at the moon, for moon, here is one complete revolution, and it started from this phase and then it went it turned around and it came back here, and it also complete one rotation around its axis. So its spin or its rotation is equal to its revolution. But while doing so, Earth has already rotated around about 29 times. Yes. So while the moon was making just one rotation, Earth have already completed this 29 complete rotations around its axis. That's why the Earth is not tidally locked to the moon. Its period and its rotation is not synchronized yet. Although in future, like let's say 5 billion years from now, it will happen. But then nothing is going to make sense, because moon will be the sun will become a red giant, and it will engulf the earth and moon, just like in the Pac-Man. It's going to eat us. So it doesn't gonna make much sense, even if earth is gonna tidally lock to moon or not. So this is one point which I want to clarify, that moon is tidally locked to the earth. Earth is not tidally locked to the moon. I hope this point is clear, and now you can answer that why on earth we just see one face of the moon every single time, because we are tidally locked. Now let's answer the part 2 of the question, that why does the moon changes its shape? We call it lunar cycle. So let's look into that. So presenting you with the lunar cycle or lunar cycle, it's actually a Latin for moon. Luna is for moon. Okay, so look here. This is the lunar cycle. This happens, as I already mentioned it, for around 29.5 days. So in this time, moon have just made one full revolution around the earth and one full rotation about its axis. Meanwhile on earth, we have rotated 29 times. So it goes through various phases. The moon goes through various phases, which we call the phases of moon. So let's first learn the naming system, how we name the different phases, and then we are going to learn how they are going to look like from the earth. Okay, so let's start from the new moon. So the process begins here. First we see the new moon, then in the course of next 15 days we arrive at full moon, around 15 days. Okay, so during this time, what is happening, that we are seeing more and more of the moon. Okay, so it's the more and more surface we are able to see. So first we will see a very short sliver of it enlightened or illuminated. This is called crescent. This shape, our beloved shape, this is called crescent shape. Okay, then we see a half full moon. Moon, exactly half of its face is illuminated, so we call it half full. Then we go to gibbous. Due to the spherical shape of the moon, we see gibbous. Okay, and then we see full moon. So this phase, when we are seeing more and more of moon gradually, this is called waxing phase. Okay, so two things to remember here. This phase for around 15 days, this is called waxing phase. Now moon is going to repeat all the phases but in reverse direction. Then we will go to a gibbous, half full, crescent, and back to the new moon. So during the second phase, we are seeing less and less of moon every time. So the second phase is known as waning phase. That is, we are seeing less and less of it every passing day. Okay, so here we learn 4 words. Waxing for slowly increasing in intensity, or for slowly increasing in the part which is luminous or which is getting visible. And then another word which we learned here is the waning. that slowly and slowly we are seeing less and less of it. Also, we learned the basic shapes. One is called crescent and another is called gibbous. Now let's just put these together, and you know all the 8 phases moon goes through the entire lunar cycle, and then you will instantly sound more astronomy if you will. Okay, so let's begin with me. First is new moon. Then we see waxing crescent. So these all phases are waxing phases. Remember, and all the upper ones are waning. So first new moon, then we see a waxing crescent, then we see a half full, then we see a waxing gibbous, then full moon. We will again go back to gibbous, but this time waning gibbous. Okay, then we will be back to half full, then back to crescent, but this time waning crescent, and then the cycle will start again from the full moon. Now you know at least how to name them in the correct order. Okay, now as I said, okay, you can differentiate between a waxing crescent or a waning crescent, but for these two phases I use half full. So we also have convention to distinguish between these two phases. Okay, split this cycle into 4 parts. So 1, 2, 3, 4. Now we have 4 quarters. So the moon which appears after 1 quarter, we call it first quarter moon, and the moon which appear after 1, 2, 3, the third quarter, we exactly say the third quarter moon. So I hope now the terminology is clear. Let's move on now how this is happening and why this is happening. So now we are going to answer the why. We will begin from here again. So imagine that sun is somewhere here, and yes, it is, you know, the sunlight is everywhere, and the earth is somewhere over here, and moon is revolving around the earth, and in turn earth is revolving around the sun. So look at this picture carefully. So moon does not produce its own light. We see moon because it reflects off the light from its surface which it receives from the sun. Okay, so during the new moon, what happens, that for example, if I am the earth and my hand is the moon and sun is somewhere here, so the light is coming, but all of the light is bouncing back from the far side of the moon, and the side which is facing my face, this one is completely dark, and I will see the moon as completely dark, and that's why, and that's how we call it the new moon, where the cycle begins from. Now as the moon start to rotate or goes away in its revolution period, a very small sliver of it would be illuminated by the reflection from the sun. Okay, so sunlight are coming and getting reflected from this part, and hence we are able to see this very tiny sliver of the moon illuminated. In this case, all of the sunlight is actually reflected back in this direction, and we are not able to receive any light on the earth. That's why it seems completely dark to us. But in this situation, we are at least seeing this one. Now imagine what will happen. Now the moon is here. It's here. So like, if you will look at that like this and split it into 2, so half of it would be in the light, reflecting off the light, and half of it would be in complete darkness. So this is what we are observing at the first quarter. Then again the moon has moved more slightly in its orbit, and then because of its spherical shape we get slightly more reflected light. Previously we are getting light reflected from half of it. Now because since it has moved further away in the orbit, we can see even more of it, and we enter into the waxing gibbous. Now this position happens where, because sun is somewhere over here, I am earth and this is moon, so all of the moon is illuminated, that is the full moon. Okay, so I'm seeing all the entire disk of the moon fully illuminated as seen from the earth. Okay, now all of these phases are going to repeat in the reverse order during the waning. So now moon again slightly moves and we see again a gibbous, this time waning gibbous, and then we see third quarter. Now the moon is here, so again the half of it is lit and half of it is in the darkness, but this time the half is the opposite half. So here, if this side was in the light and this side was in the darkness, as the moon will come this side, the illuminated side will actually flip. That's why the opposite side. Okay, and then we are back to waning crescent, and here we are back to new moon and the cycle continues. I hope that was clear enough, and this explained that why we see different portions of the moon, because different amount of sunlight is getting reflected from its surface or getting bounced off from its surface. Okay, one pro tip or one fun fact is that the phases we studied here, this is as which would be visible from the northern hemisphere. If you are living somewhere in the southern hemisphere, all the phases you are going to observe would be flipped, because essentially we are standing here when we are in the northern hemisphere, but in the southern hemisphere you are standing other way around, and you are gonna see all the moon phases flipped. For example, in the southern hemisphere, this third quarter is gonna appear this part illuminated, and first quarter is gonna seen like this part illuminated rather than this. Moreover, this crescent is going to be seen like this, as if a mirror is placed between it. So everything which we discussed would be exactly flipped or mirror imaged in the southern hemisphere. Great, I hope that was clear. And what we did learn today is these points, that a complete lunar cycle takes about 29.5 days. And that is the reason that in the ancient time, the tracking of the phases of moon was a very powerful device to make calendars. So most of the ancient calendars are basically lunar calendars. They are based on the phases of moon. Second thing which we learned is what is waxing and what is waning phase. In Sanskrit, we have a different word for it. We call waxing phase as Kartik Paksh and waning phase as Shukla Paksh. Interesting. I really find it interesting in learning different concepts in different languages. What it is called in your language, let me know in the comments down below. I would be more than happy to know it. Now, what else we learned? We learned that there are actually 8 distinct phases throughout the whole cycle. Obviously, one is new moon, one is full moon, and 2 are the quarter moons or half full. So we distinguish them by saying one is first quarter and one is third quarter. So new moon, full moon, and half full. So the first quarter and the third quarter. Then we see 2 gibbous. One is waxing gibbous, one is waning gibbous. And we see 2 crescents, waxing and waning crescent. So one, this one is again 1. We just see full moon once in the cycle. So a total of 2 plus 2 plus 2 plus 1 plus 1. So a total of 8. We see 8 different or distinct phases throughout the lunar cycle. And last but not the least, we also learned what is tidal locking and how reflection is playing a role here. At this point, I would like to mention just one small some small detail. You might wonder, or you might ask, okay, if that is the case, that moon is here and sun is somewhere here, then why we are not getting solar eclipse here, or why we are not getting lunar eclipse here? So actually, because the moon's moon's orbital plane is inclined with respect to Earth's orbital plane. So if Earth has a plane in, let's say, this direction, so moon is slightly inclined. So this inclination is around 5 degrees. That's why we do not see the solar and lunar eclipses every month. If the plane of Earth and moon orbital planes were perfectly aligned, in that situation we will see a solar eclipse and a lunar eclipse every month, but we don't because of this tilt, 5-degree tilt between the orbital plane of Earth and the moon. I think this deserves its own video. In a separate video, I'm going to explain how eclipses occur and why they are so rare. But the main answer is the slight tilt between the two orbits. So I hope that was helpful, and if you have further doubts, I will strongly encourage to perform this experiment. Okay, so take like a pen and stick a ball on the top of it. Make a light source for yourself and then try to observe the ball from your perspective, from your point of view, and what you will notice is the phases on the ball. Different part of the ball would be illuminated. Okay, so for example, here this is new, this would look like a new moon because the ball which is illuminated is away from you and the ball which is in darkness is towards you. So this is new moon, you are not going to see any moon. However, in the opposite side, now all the disc of the ball would be visible. So that's happened during a full moon. So these at the ends represents the full moon, and in between we have various phases. For example, here the F, this is going to be a crescent. What kind of crescent it is going to be? Because it is increasing, this would be a waxing crescent. So that is F. This is how it's going to look like. At G, it's going to look like half full, and at H, it's going to look waxing gibbous, and so on and so forth. So I will strongly encourage you to do this experiment on your own to better understand this. But I hope after watching this video you would be able to explain it like a real scientist with, you know, all the fancy terms: waxing, waning, crescent, gibbous, and so on. And now, since I have answered both of your questions, if you like this video, give me a thumbs up, and thanks for watching. And keep visiting my channel for more such cool content. If you want to hear about certain topic, let me know down in the comment section so that I can prepare a video on it. With that, bye bye, I'll see you next time.